Bismillahirrahmanirrahim. Assalamualaikum and good morning to all. I, Adiana Ghazali, will be the moderator for plenary session for this morning. Ladies and gentlemen, before we begin with our ceremony this morning, I would like to remind all the participants to mute your mic. I would also like to encourage you to download the Opecs virtual background to be used throughout the program, and please fill in the attendance form provided in the chat box. Again, I would like to remind all participants to mute your mic. We will now begin the second day of Opecs 2022 with our plenary speaker, Professor Dr. Engineer Zainal Ariffin. Currently, Prof. Zainal is a research professor at Research Center for Oceanography, National Research Innovation Agency, Indonesia. His research interest is in the fate and effects of contaminant, specifically metals in marine environment and Indonesian seas processes. He has vast experience in science management and currently serves as the executive director for the National Committee of IOC UNESCO program. Prof. Zainal also received various awards locally and internationally, such as UNESCO MAB Young Scientific Research Grant Award, CIDA Fellowship, President Stipend SFU Canada, Satya Lancana Karya Satya, President Republic of Indonesia. Without further ado, I would like to welcome Prof. Zainal to deliver his talk entitled Ecotoxicological Research in the Framework of Sustainable Development Goals. Prof. Zainal, the mic is now yours.
First of all, I would like to thank to Prof. Ong Meng Chuan for inviting me to the first Ocean Pollution and Ecotoxicology Symposium. My presentation will not focus on doing ecotoxicology work, but I will share my perspective on how ecotoxicology research subjects in the framework of Sustainable Development Goals, how we contribute to the 17th goal of sustainable development set during UN Ocean Conference in the year 2015. My presentation will consist of 5 parts. Firstly, on what is the regional issue in marine environment, and then secondly, on ecotoxicology in sustainable development goal context, followed by development of ecotoxicology research in Indonesia, particularly, and fourth, future ecotoxicology research, and finally, the take-home message for all of us. Let me begin. From my humble understanding, there are 3 main issues related to marine environmental problem or issue here. Firstly, pollution in coastal water, unsustainable fisheries activities, sea level rise, and land subsidence along coastal area. This is what we have. I think the problem that we are facing at the moment. Most estuary, bay, and coastal of small islands are facing land-based pollution because of untreated waste coming from urban housing or from the industrial area due to bad treatment plant system. Yeah? Unsustainable fisheries activities, both fishing technology and aquaculture activities, partly contribute to the negative impact on marine ecosystems. In the case of Indonesia, overfishing is commonly found in most fisheries management areas, especially for small-scale fisheries. Aquaculture are much better conditions compared to fishing industry at present. However, in the future, aquaculture activity potentially will contribute to the state of coastal ecosystem. Sea level rise and land-based subsidence along the coastal area, the issue of climate change has impacted many coastal ecosystems. The impact of climate change becomes severely bad, especially in several metropolis cities, and rapid development causes land-based subsidence. In the case of Indonesia, the north coast of Java Island has experienced regular flooding due to combining processes of sea level rise and land subsidence. Yeah? Overall problems affecting condition of many small community living under economic hardship. Under Ocean Science for Sustainable Development, if you look at the document, by 2030, actually the whole community or the community, yeah, we would like to see our ocean as a clean, healthy, and productive. The challenge is, firstly, we have to understand the fate and effect of pollution and mitigate the source of surface of pollution. Second, the challenge is to protect biodiversity and restore degraded ecosystems. And the third is adaptive and mitigate the impact of climate change. So we move to ecotoxicology research in SDG context. So I share here 17 goals of sustainable development, what was declared 17 years ago during UN conference in New York. Yeah. From 17 goals, goal number 14 here, life below water, is strongly linked with ecotoxicology research on marine pollution. The objective of this the objective of number 14 goal is to conserve and sustainability use the ocean, sea, and marine resources for sustainable development. So here we show 10 targets that we have to achieve by 2030. Yeah? Sorry for this bad for my PowerPoint. Yeah. So I will share again with Ocean Decade, UN Decade of Ocean Science for Sustainable Development. Under the goal of 14, IOC UNESCO undertakes a number of ocean-related activities. There are at least 7 from my understanding. Yeah, clean, healthy, productive, predictive, and safe ocean, as well as accessible ocean and inspiring ocean. So for our group, actually, for ecotoxicology group, we focus on clean ocean. So here I share the target goal number 14.1 and 14.3, as well as 14A. Reduce marine pollution, reduce ocean acidification, and increase scientific knowledge, research, and technology for ocean health. Under the goal of 14, here we share the target, by 2025, prevent and significantly reduce marine pollution of all kinds. Even though at the global level, the indicator just focus on two, on plastic litter and nutrient, excessive nutrient, but other contaminants or pollutants are also important to be studied. Target number 14.3, minimize and address the impact of ocean acidification with indicator of average marine acidity measure at certain locations that has been agreed among the scientists in our region. And the target 14.A increase scientific knowledge, develop research capacity, and technology. The issue of funding also raised under the decade of the ocean science. So how ecotoxicology research contribute to the sustainable development? Here I show some examples. Our research activities, our research activities strongly linked with goal number 6, clean water and sanitation. Of course, with goal number 14, life below water, as well as life on land. This our research, plastic litter, pharmaceutical products, oil pollution, heavy metal, and PCB is strongly, all this research is directly linked with these three goals. While indirectly also linked with other SDG goals. For example, SDG number 3, good health and well-being. I think if our research contributes to the good of information provided to the policymaker, so the policymaker can use our result of research for achieving the SDG. Here I share the development of ecotoxicology research in Indonesia. In Indonesia, at least we can divide into 3 periods of research activities. During 80s, 90s, most of the work on observation or monitoring on contaminant in 3 compartments, in water, sediment, and biota. And in 1990 to 2000, so a lot of activities, developing toxicity tests, analyze acute toxicity, bioassay, as well as bioremediation and bioindicators. The second period, actually, research more sophisticated in Indonesia. The work focuses on metal speciation, bioremediation, as well as developing bioindicator species. Bioremediation, especially during the last 10 years second period, we focuses on bioassay and bioindicator using metacopy and amplitude. And third period, actually we consider in the last 3 years or 4 years, we are really in a stagnant condition, even though research was done at small scale due to COVID-19. Yeah. So this is some example of activity that we did during period of second period in 2015 and 2020. Yeah. So we did a lot of laboratory work under cooperation ASEAN-Canada Marine Science program with Canadian government. Yeah. So we use various testing to support national government in protecting marine resources. So what is the future of ecotoxicology research? So I think this is the last part of my presentation. We understand that the issue of climate change has dominated all our research. Human activities, both in land and in water, become increasing. The issue of nutrients has not been solved for almost, I think, 30 or 40 years. Yeah. And then now coming with a plastic waste as a new emerging contaminant, yeah, pollution. So when we hear the presentation of Dr. Kenneth yesterday, that there are about 335,000 new chemical products that will be produced and used. So this is really scary from my perspective, right? Because there will be many or even a lot of chemical contaminants emerging in the next 10 years, 10 or 20 years. Yeah. Therefore, the program of Clean Ocean, we have to focus on reduce pollution, develop technology, as well as establish data and management system. So if in our region can have a networking or develop a regional research program, I'm sure we can not make it really clean, but at least reducing contaminant or pollutant will have marine life and ocean productive ocean. Yeah. So this is some of the emerging pollutant. Yeah. Issue on microplastic. This is the research is quite interesting. So how the influence of plastic litter, microplastic with food using zinc as a contaminant. So they are using two components of research in a laboratory. This is also quite alarming, especially on pharmaceutical products. So this is the work in Indonesia done by my colleagues in university. So how contaminant from pharmaceutical and using antibiotics in us can harm many marine life. The issue on oil pollution, this is, I think, a chronic issue, especially for our region. We knew that oil pollution mostly coming from land base, right? But if the accident occur, for example, in Malacca Strait, because I heard that about 60% of oil from Middle East to East Asia was past Malacca Strait. So this is the red color is showing the tanker, oil tanker coming from Middle East to East Asia. So this is quite interesting topic in the future in the area of modeling as well as on bioremediation. So in summary, my talk, there are two at least here. First, ecotoxicology research has to focus on solution, not to the current pollution problem, not only for publication, yeah, not research for research, but also or science for science, but also we have to provide a solution to the industry, community, as well as to policymakers. And research and development on ecotoxicology need to carry out under multiple pollutant exposure experiments. We try to mimic the situation in nature, because in nature, the research, the contaminant, not only one pollutant, but they are a cocktail of pollutants. Yeah? So the last message, I think, if it is possible, it will be good if we have a regional research network established as a vehicle to exchange knowledge and technology. And I think that's my presentation. I would like to thank to all teams at UMT for providing me to speak in this excellent forum. Thank you very much.
Okay, thank you very much, Prof. Zainal, for enlightening us on the importance of ecotoxicological research in protect our environment and preserve the existing ecosystem for future generation in line with the framework of SDG right now. So, ladies and gentlemen, now to proceed with the next session, I will hand over this platform to Dr. Roswati. Thank you, Prof.
Thank you.
Thank you very much, Dr. Adiana. Assalamualaikum, good morning, and hello, everyone. Roswati Maamin will be the chairperson for these sessions. It is with special excitement that I'm pleased to welcome Dr. Shiye Zhao as our next invited speaker. Allow me to introduce Dr. Shiye Zhao. Dr. Shiye Zhao, a marine biologist and environmental chemist from Japan Agency for Marine Earth Science and Technology, has been involved in microplastic studies since 2014. With his passion in this field, he secured a postdoctoral position at Woodhull Oceanographic Institution, United States, and became an associate researcher at Florida Atlantic University Harbor Branch Oceanographic Institute before joining JAMSTEC in 2020. His current research focuses on developing a mechanistic understanding of how plastic debris influence the ocean ecosystem by employing modern tools of multidisciplinary science. Most of his publications have become a significant reference to other researchers in this field worldwide. Today, we are privileged to hear Dr. Zhao speak on microplastic in the ocean interior. Now, ladies and gentlemen, I welcome Dr. Shiye Zhao to present his talk. The room is yours, Dr. Zhao.
Okay, thanks, Rose, for your introduction. Hello, everyone, and welcome to my talk. So, yeah, first I have to share my screen. Hi, Rose. Can you see my share screen? So my slides is okay from your side?
Very clear.
Yes, we can see.
Okay, good. Hello, everyone. Thanks for the UMT providing this opportunity to share my work with colleagues probably in the Southeast Asian. Yeah. And in the following slides, I would like to talk about our most recent study on microplastics in the ocean interior. So the oceans and the seas are the major sink of plastic debris. Every year, about 8 million tons of plastic debris enter the ocean. However, recent pan-oceanic surveys report ranging from 7,000 to 217,000 tons of plastic floating in the open ocean surface water. This huge disparity between the 8 millions and this number means that most of the plastic debris entering the ocean has gone missing. Several mechanisms have been proposed to explain this disparity, such as traps in the coast, ingestion by marine biota, and sinking out of the surface layer, degradation into smaller particles too small to be caught. So by considering the mechanisms of plastic sinking and degradation, we hypothesize that microplastics are permeating the ocean water column, especially for the small-sized particles in the offshore plastic accumulation zone, like the subtropical ocean gels. So to verify this hypothesis, we conducted a simple collection in the South Atlantic gel in January 2019. This map shows the predicted floating microplastic distribution in the South Atlantic gel. So where the red and the blue region indicate, they contain high and low abundance of plastics in the sea surface. So during this cruise, three collection techniques were used simultaneously, including in situ pump, mountain-net, and multi-net to collect microplastics in the ocean water column. So with the in situ pump, samples were collected from the 10 meters down to over 5,000 meters at 4 stations, A, B, C, and D. So at the same time, 5 mountain-net and 3 multi-net samples were also collected. So back to the lab, samples collected by pumps were purified and concentrated on anodic filter. To identify their chemical nature, the whole filter was scanned under FTIR spectrometers. So for the net samples, plastic-like particles shown in this image were picked out and identified by FTIR and the ATR mode. So here is the result part. So this figure shows the microplastics in both pump and net samples. Microplastic abundance of pump samples are represented in this figure are represented by these blue and orange dots. Abundance of net samples represented by the diamond, square, and triangle shapes here. So plastic abundance in the mountain-net samples were ranged from the 1.4 to around 3 particles per cubic meters, and the multi-net sample have even lower abundance. But we found that plastic abundance in the in situ pumps are between 13 to over 200 particles per cubic meters. Overall, microplastic in the net-based samples, including mountain-net and multi-net, were at least 2 orders of magnitude lower than the abundance sampled by in situ pump. So this abundance disparity indicates that microplastics in the ocean have been largely underestimated by net-based and visual detection-based techniques. So let's see the horizontal distribution in the upper layer of the waters. So the highest abundance in the pump captured microplastics was detected at station A and followed by station D. So station B and C have lower abundance in the surface layer. So based on our, the modular floating plastic distribution, station A and D are located in the blue and low contaminated region. So station B and C are located in the heavy pollutant region, based on the modeling results. That means station B and C, which have a higher contaminated sources, should have a higher abundance than station A and D. However, our observation, obviously doesn't support this. So the average microplastic abundance in our pump samples was significantly higher in station A and D than station B and C. So microplastic abundance in our mountain-net samples show a totally different trend from our pump capture microplastic. Our mountain samples data represented by these green bubbles. They display a clear trend that plastic abundance increased with the proxy to the center of the South Atlantic gel. So this also agrees well with the Erickson's observation in 2014, which their results are indicated by the counterline in this map. They also observed the same trend in the net collected microplastic abundance. So overall, our data shows a conflicted distribution between the net collected microplastic abundance and the pump collected microplastic abundance in the in the regions of the plastic accumulated zoo. So several known processes probably provide a explanation for this mismatch between the pump capture microplastic and net-based microplastics. Firstly, it could be partially explained by physical process. A previous modeling study predicts that 60 to 80% floating debris in the South Atlantic gel was from the South American. So because the basin scale circulation largely follows along the isolines of the sea surface height, so this floating these floating debris from the west boundary of the South Atlantic would likely arrive firstly at station B and followed by station A, D. Finally, they arrived at station C. These floating debris probably dispersed along this proposed route, which may partially contribute to the lower microplastic numbers in the near surface layer of station C. So in addition, the velocity fields and sea level anomalies at each station show that station A and station D were closer to the core of the anticyclonic eddies than station B and station C. So previous research has approved that microplastics particles were prone to aggregate at the edges of the anticyclonic eddies. So, okay, let's have a look at the vertical distribution of plastics. So microplastics are, from this image, we can see microplastics are present throughout the water column in the South Atlantic gels. So plastics were found all the sampling depths, except one depth, the deepest one at the station B. So plastic abundance at stations A, B, D typically decreased with the depth. But station C showing a striking increase of over 20-fold at depth. So this result indicates that different mechanisms in the plastic flux highlighting the role of the local ocean circulation in the distribution of microplastics. So why did the bottom waters at Station C have so high plastic abundance? So firstly, the depth integrated current velocity clearly shows that the velocity of the bottom currents at Station C was apparently lower than the other three stations. So this low intensity of currents probably contribute to trapping microplastic particles in the deep waters. In addition, the 3D transportation of particles also help to shape these patterns. Through NMDS analysis of the polymer composition at each depth, we found a higher similarity of polymer types between the deepest sample at Station C and the surface sample at Station A and Station D. So this results, this analysis implies that the oceanic upper layers with higher microplastic abundance around Station A and D could be a sources for plastic particles for the deep layer near the Station C. So the size distribution showed all microplastics captured by pumps peaks around 40 micron. The size ranged from the 20 micron to over 300 micron. So more importantly, 97% of plastic particles are smaller than 150 micron. Microplastics smaller than 150 micron is critical because they are able to entrap the within biomass, causing potential system exposure. Regarding the polymer composition in pump samples, polyamide and alkyd resin, are the major polymers, followed by polypropylene and polyethylene. So polyamide is a typical polymer found in fishing nets and ropes. The southeast of Atlantic Ocean is a hotspot for fishery, hence large numbers of polyamide found here may be from the sea-based sources. However, polyethylene and polypropylene dominate the plastic particle collected by nets. So this inconsistent polymer types between pump samples and net samples indicates that plastic composition changed with sampling depth and particle size. So interestingly, our data also show a tendency of increasing shape factor with decreasing particle size. It means that small microplastic captured by pump are close to spheres in shape. So our previous study have proved that a larger aspect ratio could enhance microplastic injection. So moreover, comparing the sinking speed of the pump captured microplastic particles to large microplastic and fecal pellets in previous studies, we can see that the predicted sinking speed of pump captured particles were extremely slower than these large particles and fecal pellets. So These low setting rates of microplastics imply a higher dispersion and a even distribution and a longer lifetime in the water column. As well, higher carbonyl index were also observed for pump collect microplastics than those collected by the nets. So this could be explained by a surface ablation mode of fragmentation, so which a large number of small daughter fragments detach from the parent fragments due to the weathering. These smaller fragments are usually more weathered. So a similar result was also observed in plastic particles from the North Atlantic Ocean. So where smaller particles, plastic particles, are more oxidized than the larger ones. So previous research reports that highly aged microplastics are preferred by the marine life. So based on these results, we conclude that disparate features of plastic inventory are found between pump and net samples in terms of microplastic abundance and chemical nature. Nets have been undersampling the smaller microplastic fraction, which is actually not missing when using high-volume filtration pumps. High abundance microplastics exist within the surface water to the near seafloor waters of the remote South Atlantic gel. So yeah, compared the net collect large plastics, smaller microplastic captured by pumps are more highly weathered, have a longer lifetime in the water column, and concentrated in the low current regions, implying a serious threat to the subtropical gel biome through uptake. So all these results suggest that microplastics in the ocean still remain largely understudied, especially for the smaller microplastic. So a more holistic view is necessary in the future. So finally, I would like to acknowledge the funding source supporting our work on this talk. I also must give credit to my co-authors on this talk. Okay, thanks for your time. I will take any question and comments.
Okay. Okay, I can't thank you enough for an impressive and informative talk. It was really good finding, unveiled the distribution of small microplastic in the water columns, which have high potential to be ingested by other organisms, including zooplankton. And most importantly, this study, I think, cover in one of the 6 main influentials gyre. I have few questions here, Dr. Shiye Zhao. In regard to the method of sampling, I know it's very limited study available on microplastic distribution in the water columns. Since you're using different method, what will be your suggestions? Okay, that's the best method to practically focus on several depths for microplastic sampling in the seawater and using water pump instead of net sampling?
Yeah, that's a nice, that's a good question. So basically, that depends on your research question. But if you want to give a a objective understanding of the microplastic pollution in your research region, I suggest you can use multiple tools to to collect the samples. The pump samples can capture lots of the smaller particles, and they can also allow you to capture the sinking particles and the solvent particles. But the net the net-based techniques only allow you to get the large particles. So that depends on your question, but if you can do it, you use both of the techniques. So that's my suggestion.
Oh, okay, thank you. Dr. Shiye Zhao, you can stop sharing your slide, maybe. It's
I'm
good to see
finding
your face. Well, yes.
how to
Yeah, stop sharing.
share.
I think,
Oh,
okay.
okay. Yeah, I see it.
Okay, one last question, maybe. In regard to the size classifications, how actually do you differentiate those by individually sorting them following the respective size?
Sorry, I didn't get your question. Sorry. Pardon.
No, I mean, it's like because you mentioned just now about the size classifications. How do you actually you classify or differentiate them by individual sorting them following the respective size?
No, I just scanning that. So the machine will generate a map of all the particles on the filter. So you can get all the particle, physical information and the chemical information.
Okay. I think one last question before I proceed to the next. Okay. I think you mentioned something just now about the zero detection in your graph.
Yes.
Yeah.
Yes.
Maybe you can explain further on that.
Sorry.
Maybe you can explain further on that. Does that mean they have no detection or no microplastic using multinets?
No. No. It's a pump sample. We didn't find any particle in that samples. No.
Okay, but you didn't analyze the sample.
No, I analyzed, but I didn't find. There's
I
no
see.
particles, no plastic particle be
Okay.
identified. Yeah.
All right. I think that's all for now. With that, thank you again for the wonderful speech on microplastic, Dr. Shiye Zhao. Now let's get to the next sessions. Over to you, Dr. Nurul Shahida. Thank you again, Dr. Shiye Zhao.
Thank you.
Okay, Assalamualaikum and a very good day to all. Okay, here we are at the session 4 of the first Ocean Pollution and Ecotoxicology Symposium 2022. I am Nurul Shahida Radzwan, the chairperson of this session. This session 4 is brought to you by Opecs 2022 to exclusively discuss topics on findings, issues and matters related to the abundance and occurrence of microplastics in our oceanic, coastal, and other related ecosystem. Sharing their works today in the session 4 are 6 speakers who are going to talk about their interesting and compelling findings on, of course, microplastics. Also, joining us today are 2 juries of the session. So let me introduce you the juries. The first one is Associate Professor Dr. Kesavan Bubalan, and the second one is Dr. Suvik Asau. So before we get started, a few housekeeping announcements. The first one, there will be no presentation by Opecs 034. due to health matters. And then the second announcement, should you have any questions regarding to the topic of the speakers that lingering in your mind, please do not hesitate to post your questions in the chat feature of the WebEx. And please also don't forget to indicate the name of the speakers, followed by your questions. And I shall read the question shortly after the final presentation has been made. Okay, so now all attendees, sit back and get comfortable because I'm going to introduce our very first speaker of the session, which is Dr. Defriona, that's going to share their findings on microplastic contamination in mollusks from mangrove forests of Situbondo, Indonesia. So Dr. Defriona, the WebEx is yours.